Okay, ladies and gentlemen, we're going to be watching linear equations in two variables. It's lesson 8.2, and make sure you're taking notes, writing down key terms or key procedures, as well as any questions you may have. And remember, as always, you're looking for that learning target. Why are you watching this video? Oops, before I do that. Okay. Okay. So we have an equation here, word problem, and I'm actually not so much worried about what this word problem is. If you wanted to stop and watch, you're more than welcome. What I want us to focus on is right here. An example of an equation in two variables is 2x minus y equals 5. A solution of an equation in x and y are ordered pairs that produces a true statement when the values of x and y are substituted in the equation. So one of the things we need to know is if you have an equation that has two variables, you do not have just one answer, but you have infinite number of solutions. So you have possible of multiple or infinite answers. But be careful, just because there's infinite solutions does not mean that all solutions are going to make that statement true. We need the statement to be true. So how do we do that? Well, let's see. Example 1, tell whether the ordered pair is a solution of x minus 3y equals negative 1. So I'm going to take my ordered pair, and I'm just labeling this in case you have forgotten that these are my x and y's. So wherever I see an x, I'm going to put 4. Wherever I see a y, I'm going to put 2 using this equation. So I have 4 minus 3 times 2 equals negative 1. So I have to do PEMDAS. Negative 3 times 2 is going to give me negative 6. So 4 minus 6 equals negative 1. Well, 4 minus 6 gives me negative 2, keeping my negative 1 because I haven't done anything. Does negative 2 equal negative 1? No, it does not. So this is not a solution because it does not make this statement true because negative 2 is not the same as negative 1. So again, my x and y values, and I'm going to substitute those in. So where I see an x, I'm putting a 2 minus 3 times 1 because that's the value for y equals negative, oh my goodness, I did something there, didn't I? Okay, so negative 3 times 1 is going to stay negative 3 because that would be the identity property of 1 for multiplication, I should say. So 2 minus 3, negative 1. And then I keep all of that. So negative 1 equals negative 1, and that checks. So this is my one of my solutions. Remember, there's infinite solutions, but I'm looking for the one that makes the statement true. Take a moment to pause this video and capture down all the key information, especially the FYI. Okay, so I know many of you have felt like this young man before, especially when it comes to math. That makes me sad, but even myself, I've gotten frustrated with it because that's just the nature of math. So, the number of pages that Donald has left, oh, by the way, P is going to be representing pages that he has left to write for his 30-page research paper depends on, sorry as I yawn, how many days, D, for days he writes 5 pages per day. This situation can be modeled by the equation. So I want you to take a moment, pause the video, and decide what does P represent, 30 and negative 5 in the D. Okay, thank you for coming back. Hopefully you've come up with P is for pages, because they did tell us that, and that you came up with D for the days, and right here it tells us 5 pages per day. So that means you're going to be multiplying, and since we're reducing the number of pages, we're going to be reducing it by 5. And he has a total of 30 pages. So D is for days, P is for pages. If 0 days, he's has not wrote one page for 0, hasn't done anything. So you put 0 in for the D. Well, 0 times anything is 0. So we get left with he has still 30 pages to go. Well, that makes sense. If he hasn't written any, he would still have all 30. Well, at day 1, we can plug a 1 in, and 1 times negative 5 is going to give me that negative 5. So 30 minus negative 5 is going to give us 25. So we see that he's decreasing the number of pages he has left to write. So for day 2, I plug that in for 2 and for the day. And so negative 5 times a 2, and I'm just going to kind of put a 2 there for this point. That's going to give me negative 10. Okay, so now that I have negative 10, 30 minus 10 is going to give me 20. Well, let's see. Let's go for day 3. Let's just complete our table here as it's asked us to do over here. 3, so if I put 3 in, that's going to give me a negative 15 because 3 times negative 5 is negative 15. 30 minus 15 is going to leave me 15 pages. Okay, so how many days does he need to finish his paper? So if he's doing this 5 pages a day, well, we can see at 3 days, he's halfway through, right? So can we double that and say that in 6 days, he will have, sorry, 0 pages to go. And I could make a 6 here and a 0. Now, if you don't see the pattern easily, you can always go and do the algebraic equation where you're solving for the unknown. If we know that he started off with 30 pages, and we know he's doing 5 pages per day, but we don't know the day, but we do know we want to get to 0. You can solve for D by subtracting a 30 to both sides. When I do that, I get negative 5D. I get this, right? Negative 5D equals negative 30, and I'm sorry, that's really hard to see. And so if I have negative, I'm going to write it over here so we can see it easier, D, negative 5D, equals negative 30. If I divide both sides by negative 5, that's going to go ahead and make that identity property of, so we just get 1. And this is being divided by negative 5. Well, negative by a negative is going to be a positive. 30 divided by 5 is 6. So we can do it that way as well. So there's more than one way to obtain the answer. Go ahead and pause and take your notes, and I go ahead and erase this. Okay, so ladies and gentlemen, we're going to be talking about graphs, and the graphs is a really nice way of looking to see. A linear graph is going to be a line. So go ahead and feel free to copy that down when you pause. So for example, I have y equals 1/2 x minus 1. Well, I need 5 points to get a nice line, and I want to spread them out a little bit, but I don't want to pick crazy numbers. So 1, I always go for 0, because 0 times anything makes it 0. So this is going to make this 0, and if that's 0, I just get left with that negative 1, which says y equals negative 1. That's a nice easy one. Then I see that I'm dealing with a fraction, and its denominator is a 2, so I want to deal with multiples of 2. So I started with negative 4. So if I take and put negative 1/2, and I multiply that by a negative 4, I'm going to get negative 4 over 2. And that reduces to negative 2. So now I have this as a negative 2. All of that is now simply a negative 2. So negative 2 minus 1 is going to give me negative 3. Now if I take this and I multiply it by a negative 2, so let me see if I can have a little bit more work. And I multiply that by a negative 2. That gives me negative 2 over 2, and that's going to simplify to a negative 1. Well, if I have a negative 1 now for all of this, negative 1 and a negative 1 gives me a negative 2. And you can start to see there's a pattern, and it's really important to put these in numerical order from least to greatest so that you can start to see kind of patterns. What's happening when I'm doing these things? So if I put a positive 2 in and I multiply it, I'm going to get a positive 1. Positive 1 minus 1, well, that cancels, so I get a 0. You probably could have predicted that was going to be a 0, right? Because we seem to be increasing by 1 for every y. Well, if I put a positive 4 in, for this, I get 4 times 1/2 is a positive 4 over 2, which is going to give me a positive 2. If this is all positive 2 now, when I take away 1, I get left with 1, and you could have predicted that. So let me go over here, go to 0. I just like to start at 0. And then I need to go down 1, and that point is my 0, -1, and then I'm going to go over, then I'm going to start filling these pieces in. So I'm going to go over 4, 2, 3, 4. It says I'm going down 3, 1, 2, 3. And then I go over 2, so to the left, 1, 2, and that's all the minus sign tells me is direction. And it says I'm going to go down 2 because it's a negative sign. Then I come over here and it says I'm going over positive 2, but I'm not increasing any. I'm going to stay right there at the x-axis. And I go over 4 for this next one to the right. 1, 2, 3, 4, up 1. And now if I was really good and talented, which I assure you I'm not, I could easily connect these. And I'm trying to see if I have a little, oh, look at that. There's a line. So let me do that. Again, as I said, I'm not that great, but even with that, so you can see that is a linear, it's a line. We can actually even say that's an increasing line because as we read left to right, it's going up, like we're going up the hill. So make sure you pause, take the notes you need to do. I'm going to go ahead and erase these. If you have some questions, please rewatch this, come into class with your questions. One little point here, it says every point on the line is a solution to the equation. So that line that I had drawn, every point on that line would be a solution to this equation. Okay, I'm actually going to pause this and go ahead and make a second video because this is getting long and I don't want to bore you too badly.